Hi, welcome to Math Key. In this tutorial, I'm going to show you how to find the value of x in this exponential equation in which the base and the exponent are the same. So, let's get started. So, the first thing we're going to do is to simplify the right-hand side in such a way that the base and the exponents will now become the same. So, we need to simplify. We need to simplify the right-hand side so that both the exponent and the base are in the form k raised to power k. So the right hand side will be simplified to be in the form k raised to power k. That means we're going to keep the left hand side. So now let's see what we have here now. Therefore, x raised to power x equals to raised to power the square root of 200. So we're going to keep the left hand side. We'll keep the left hand side. We'll keep this side and simplify this side now. So let's go. Now at the left hand side, this is 2 raised to power 200 is written as 100 times 2, which is now written as 2 raised to power the square root of 100 times the square root of 2. So this is the law of indices, the law of surd, the law of surd. It says that a, b in the square root, that's the square root of ab, is equal to the square root of a times the square root of b. So this is the law of surd. So let's take note of this law. This law is going to help us, so we need to take note of that. Now, from here now, that means this is equal to 2 raised to power the square root of 100 is 10 times root 2, that's times root 2. So you see this, which is now equal to 2 raised to power 10 root 2, power 10 root 2. From here, what we're going to do now is to split this power into 2. So now let's manipulate this. So we'll get 2 raised to power 10 root 2. We're going to split this 10 into the product of two factors, 5 and 2, to get 2 raised to power 10. That's 5 times 2 root 2. So 5 times 2, giving us back the 10. So what we're going to do now is to allow the 5 to enter. So the 5 enters the bracket to raise 5, to raise the 2 to the 5th power. So we get this raised to power 2 root 2. So at this point in time, what we are going to do now is to manipulate the power inside using the first law of indices. We're going to manipulate the power inside using the first law of indices. So this is now equal to 2 raised to power 4 times 2 raised to power 1. All right, so that's the first law of indices in bracket raised to power 2 root root 2. So what we did here is the first law. The first law of indices, which says, for example, a raised to power p times a raised to power, let's say k, that's the first law of indices, equals, you take one of the bases to get a raised to power p plus k. So this law, this is the first law of indices which we applied here. What we only did is that we split this thing 4 plus 1, which gives us back this 5 now. So p plus k gives us the p plus k we have here. We picked one of them and added the exponents together. So at this point, what we're going to do now is to manipulate this now. So to manipulate this, we're going to rewrite this as 2 raised to power 4 times 2 raised to power 1. We're going to manipulate this by introducing a 2 over 2. So we're going to introduce a 2 over 2 times this normal power we're having here. That's 2 root 2. You know, 2 over 2 is 1. So nothing has been done here. No harm has been done to this whole thing now. So what we are going to do at this point is that we are going to let the 2 at the bottom, that's 1 over 2, to come in and let this 2 multiply to root 2. So now this implies 2 raised to power 4 times 2 raised to power 1. We'll close the bracket, and now we'll split this part to get 1 over 2 times 2, that's this one here, then times 2 root 2. 2 root 2. So we haven't done anything wrong here. So this is 1 over 2 times 2, which gives us the 1 we have here, and everything is still okay. So now 1 over 2 will have to enter inside. We'll multiply the 4, and then we'll multiply the 1. Then this 2 will multiply this 2, root 2. So now what it means is that we're going to take this up. Let's take it up. And then from here, this automatically implies that 1 over 2 times 4 gives us 1 over 2 times 4 gives us 2 raised to power 2, then times 2, 1 over 2 times 1 gives us 1 over 2. We close the bracket, and then 2 times 2 gives us 4 root 2. So at this point, it implies 2 raised to power 2, of course, is 4, times 2 raised to power half, which is written as root 2. So we close the bracket, raised to power 4 root 2. 4 root 2. So now this is now equal to 4 times root 2 gives us 4 root 2. We close our bracket, raised to power 4 root 2. So 4 root 2 raised to power 4 root 2. So at this point, you see that both the base and the exponent are now equal. So the base and the exponents are now equal. But what we are going to do is to simplify. We're going to simplify this. Let's simplify this. So we're going to simplify this to get what is this? This is 4. So 4 becomes 4 squared times 2. So as the 4 enters, it becomes squared. So times 2 raised to power, the same thing happens here. So 4 squared times 2. This is another law of surd, another law of surd, another law Another law of third. Another law of third. It says that a root b is equal to the square root as a is entering as a is entering this third, it becomes squared, it gets squared, and it multiplies the b you see there. So you see this b. So this is another law of third. So that is what we have applied here now. So that's equal to, that implies 4 squared is 16, which is 16 times 2, all raised to power 16 times 2, the square root. And now, of course, this implies 16 times 2 is the square root of 32 raised to the power of the square root of 32. You see this now? At this point, let's recall, first of all, we'll go back to the original question. Here we have x raised to power x equals 2 raised to power 200. So this x raised to power x, we said, is what we have simplified to this whole thing. So at this point, it means that the what do we have here now? The x raised to power, that means this whole thing is equal to x raised to power x. So we can say that therefore x raised to power x is equal to this whole thing here now. So that's root 32 raised to power root 32. So now by comparison, x is equal to the square root of 32. So you can see x equals 32 and x equals root 32 also. That's the root 32, x equals root 32, x equals root 32. So x equals root 32. This is the value of x. So now what we are going to do is just to check. Let us check if this answer is correct. Let's check if x is truly root 32. We want to verify this. Let's verify this now. Now, let's recall that x raised to power x is equal to 2 raised to the power of root 200. This is the original question. X raised to power x equals to 2 raised to power root 200. So from what we have seen now, we can imply that if x is actually root 32, that means this place, the left-hand side becomes root 32 raised to power root 32, that's this now, equals 2 raised to power root 200. So what we are going to do now, we are going to verify from the left-hand side. Let's verify the left-hand side. We're going to verify this left-hand side to see the accuracy. Now, to verify this left-hand side, we're going to simplify the left-hand side. Let's simplify the left hand side. We're going to simplify this left hand side to see whether it's equal to this. Let's check now. So now let's go with this now. At the left hand side, it implies it implies that 32 raised to power half, all right, then times what we have here is also 32, but we're going to split it as 16 times 2. So this half here is from this square root, and this root 32 is this root 16 times 2. So we're going to go with that and see what is happening here. We're going to see. Okay, so let's be on the check. Okay. Okay, so now 32 is written as 2 raised to power 5. So it implies this 2 raised to power 5 times 1 over 2 times 16. That's root 16 times root 2. These ones are all powers. So at this point in time, we can imply that the 5 goes out. So that's 2. The 5 goes out to multiply this will give you 5 over 2. So 5 multiplies 1 over 2 to give you 5 over 2, then times the square root of 16, which gives us 4, then times root 2. So from here, this implies 2 raised to the power 5 over 2 times 4 gives us 10, then times our root 2, so which is now implying 2 raised to the power 10 times root 2, of course, is 10 root 2. Now again, we are going to apply the other law, recall that a root b is equal to the square root of a squared b. So this law, we're going to apply this law over to this power here, and that implies, 2 raised to power, as 10 goes in, it becomes 10 squared times 2. You see, this is 2 raised to power 10 squared times 2, which now implies 2 raised to power 10 squared is 100 times 2. Okay, so this now implies 2 raised to power 200. So we can now see that what do you call it now? We can now see that, let's see, 32 root 32 raised to power root 32 is now equal to 2 raised to power root 200. So you can see that this whole part here is the same as what do you call it, 2 root 200. Hence, therefore, we can say that now root 32, therefore root 32 raised to power root 32 is equal to 2 raised to power root 200, which implies that hence x is equal to what? Truly root 32.